Hi friends, myself Dr. M. Gunasegaran. We are discussing about the gas turbine technology, and so in the previous classes we have discussed about many important topics. So we will be just discussing more about the gas turbine technology and also the cycles. Okay, so that the modifications. So based on the simple Brayton cycle or simple gas turbine cycle, so we were discussing about the modifications. Those modifications again we will discuss. We will come to that topic later. Right now, okay, what we are going to discuss? We are going to discuss one of the important concept. Okay, nothing but velocity triangle. So the velocity triangle is very important in gas turbine technology. So it is not only in gas turbine technology, even if you are just studying about the fluid mechanics, so there and all will be coming across velocity triangles. So that means velocity triangles will be coming into the pictures where whenever we are dealing with the machines, okay, either it is the fluid machinery or turbo machinery. So whatever it is, okay, or okay, so based on the different assemblies and different machineries, we will be encountering the velocity triangles. Because if you want to find out the work or energy, so then we have to understand the velocity triangle, or we have to use the velocity triangle. That is the idea. Because for extracting the energy, or for understanding the energy from the machineries, turbo machineries or fluid machineries, or we can just say to find out the work. So in all the scenarios, that means velocity triangles plays the major role. So in this class we will just see how the velocity triangle is being constructed, or how to construct the symbol or in the easy way of constructing the velocity triangle. Okay, so first let us discuss about this, and then we will go to the that means to see about turbo gas turbine technology parts. That means like compressors, okay, so either centrifugal compressors or axial flow compressors, and then later on we can go for the that means turbines. So those things for these things, okay, anyway the velocity triangle is very important. So velocity triangle is plays the major role. So first let us see the symbol velocity triangle. So symbol velocity triangle, whenever we say observed velocity, okay, whenever if we have a observed velocity, let's say this is the observed velocity, this is the observed velocity component, and this observed velocity component has generally, okay, if it is inclined, if the observed velocity is inclined to the flow, then what happen, it will have a both vertical as well as horizontal component. That is the idea. So let's say this is inclined to the this, okay, so this is our horizontal position. Let's say this is your this is the reference. So this is the reference line. So with respect to this reference line, this observed velocity is inclined. So it is inclined, okay, let's say this angle nothing but this angle is nothing but theta. So this theta plays the role. So for the this velocity component to be inclined. Okay, so now this is V. Now let's say this component is nothing but V. This is V. So let's say capital V. Okay, let's say it is a V. So or in some cases we can say V or C. Okay, so we can just say V or C. Okay, both we can just use the notation. So okay, now this is okay, this can be resolved because this is the observed velocity. So observed velocity can be resolved into vertical as well as horizontal. So vertical, let's say it is the vertical, then okay, so this is nothing but horizontal. Okay, so this is the vertical and this is horizontal. Okay, so the vertical component we can say as the this one. Okay, let's say first the horizontal component. Suppose this component, okay, comes to the horizontal, so this is we say tangential component. Okay, so this component generally we say VT or CT. So VT or CT, this is nothing but it is equal to B into okay, so this is the included angle, this is V into cos theta, this is V cos theta. Then similarly vertical component nothing but we can just see as the axial component or radial component or flow velocity. So we can say in any terms, so either it can be VA means axial or we can just say VR radial. So we should not be confused with the relative term. So it is the radial. Okay, just let's say it is the radial. Okay, radial. So this is or we can say VF. Okay, so let's use only these two notations, VA or VF. Okay, for the vertical component. So vertical component, this is nothing but it is equal to, this is equal to this component into this. So nothing but this will be sin V cos theta, then this will be V sin theta. That is the idea. So V sin theta. Okay, so this now we got okay, both the vertical as well as horizontal component. Now this how this component is going to construct the velocity triangle. So that is the idea. So now symbol velocity triangle, this also we can say, that means this component, suppose if, okay, if you are taking this component to here, so if you are just placing it here, so then now this will be this component, the same component only, I am just putting it here. Okay, the same component I am transferring to here. So this is what okay, you are this. Okay, so now okay, this also becomes the triangle. So this also we can say as the velocity triangle. That means symbol velocity triangle. This symbol velocity triangle has the tangential component. That means horizontal component. Just okay, we can say it is the horizontal velocity or tangential velocity. Then we have a vertical component. Nothing but this component. Nothing but axial or radial or flow velocity. Okay, so that we can say. This is what okay we have shifted. So this is also, this is what okay we say symbol what to say, symbol velocity triangle. If from this symbol velocity triangle only we are developing modified velocity triangle. So that is one thing you have to understand. So from this symbol velocity triangle only we are developing modified or yeah. So this is one thing just we have to note down. Yes. So how okay we can develop the modified. So this component only we say yes. We say VA or VF. Okay. Now how to modify this velocity triangle? That is okay one thing. Generally what happened, the blade velocity or vane velocity or impeller velocity or okay rotor velocity or whatever it is. So because everything there will be that means the blade, okay, we may have a blade something like this. So it means it will be yeah, just we will be having the blade like this. So we'll okay, it will be rotating okay between these passages. So that means suppose if it is rotating like this in this direction, then okay, anyway we will be having the velocity, blade velocity. That means what is the tangential direction? Okay, so this blade will have the velocity, that is what we say blade velocity. So that is okay, we just say it is the tangential velocity. So here, okay, this is the tangential direction. Similarly here also we can draw the tangential direction. So these two okay lines represents the tangential direction. So in this case the tangential direction will be horizontal. Okay, so that means that is why that is the reason we say this tangential component also okay represented by blade velocity or vane velocity or okay impeller velocity. So in many terms okay we are going to call. Okay, so that means this is rotating with some velocity, so that velocity we are representing with that tangential velocity component. That means this is okay rotational component, so that okay we are having the linear component, that is what tangential component. So the tangential component okay we need to consider the tangential component also is in the horizontal direction. The tangential component, suppose okay if I am just including it here, just we say the tangential velocity. So this is our okay tangential velocity. So this tangential velocity, let's say it is the tangential velocity. So this tangential velocity we can call it as u. Yeah, this component. Yeah, this component. Yes. Okay. So because this is nothing but Vt or Ct. Okay. So then this is what okay we say this is the same point. Okay, this is what we say u, small u or capital U. Okay, so now okay what happened, this tangential this component as well as this velocity both are in the same line. Okay, both are in the horizontal direction only. So now okay both of them will be joined together. Okay, so that is what we say we can draw the new velocity triangle. It is something like this. It is something like this. This is okay, I am just drawing the new velocity triangle. This is then okay, this is our okay resultant of the absolute velocity component. So we can just say C, and this is okay nothing but this is okay, this is what we said Vt or Ct. Then okay this is nothing but our Vf or Va. Okay, so Vf or Va. Okay, so Vf or Va. So now what happened, okay now this okay this both velocity component comes in the same line only. So up to this only we just say this is what okay we say Vt or okay Ct, or we can just say this also. Okay, so this is a tangential component. So this is nothing but our blade velocity. So this is nothing but our blade velocity. So u. Okay, now what happened, now we are joining these two. Now okay the C okay absolute velocity component, this we are joining with this point. Okay, so now okay what happened, whatever the new component arises because of joining, this component only we call it as CR or VR. We can just see relative velocity, this component only we call it as relative velocity. Okay, so what we need to understand, this relative velocity will be there whenever there is a absolute velocity. Okay, so then also okay this horizontal component, this two horizontal component will be there. Okay, may be there because depends on the condition whether tangential velocity component will be there or this. Anyway, because the blade velocity will be there, blade velocity or vane velocity, this tangential, because this velocity also is tangential to the okay flow, that means that blade. So this component obviously it will be there. So if this component is 0, then what happen, we cannot have the velocity triangle. So that is one thing. Okay, so this will be there. So then this component and this absolute velocity. So whenever we have a absolute velocity and this blade velocity, then definitely there will be a relative velocity. That is what the understanding. So this must so this must be clear. So how the relative velocity comes into the pictures. So this relative velocity and may have a different positions. So relative velocity may be here or here. Okay, so it may be depends on the conditions. Okay, so as for example this theta, when theta equal to, if we say when theta equal to when theta equal to 90 degree, then what happened? When theta equal to 90 degree, our Vt, because Vt is nothing but V into, this is nothing but V into cos theta. So this is, so our Vt will be 0. So when theta equal to 90 degree, Vt will be 0. So then this component comes to the vertical. Okay, this, because this angle is theta equal to 90 degree, this component becomes like this. That means our V equal to VA, or okay, we can just VA equal to V. That's what we can say. Okay, V equal to VA, or okay, our VA is nothing but now V. So this is we can say either like this or like this. Both the ways okay, we can say. So it is very important. Okay, so when the theta is 90 degree, then axial, that means absolute velocity becomes vertical. It means our okay this V equal to VA. Okay, so that is what we have to understand. So in that case, what happened, our tangential velocity component is 0. So this is one scenario. Okay, then anyway this blade velocity or vane velocity will be there. So if you say that our tangential velocity is 0, but still we have a blade velocity or vane velocity. So that okay scenario, we can have a one symbol this. Okay, so when this condition occurs, so this velocity, that means our this is one symbol modification I am just saying. So we will be seeing many modification whilst discussing the compressors or turbines. So this is okay, we can just say now it is the C equal to V1. Okay, C equal to VA or VF. So this is nothing but our blade velocity. This component is nothing but our blade velocity U, because when theta equal to 90 degree, our tangential velocity component is 0. So now anyway this is 0, but what happened, as per the actual triangle, this triangle, as per this condition, what happened, this will be joined, so this velocity, okay, that means the relative velocity will be there, CR. So this is C and this is U, and this component is nothing but CR. So this angle we can say 90 degree. Okay, so that is what. Okay, so this is one symbol modifications based on this condition. Okay, so like this we will be having many modifications. Okay, so here okay we have drawn with the that means axial velocity or radial velocity, nothing but our absolute velocity. So in some cases the relative velocity may become axial or radial. Okay, so that case also we can found out. Suppose if you want to have a, that means radial velocity as the axial component, then we have to modify the condition. Okay, this is for the condition when theta equal to 90 degree. So suppose when the radial velocity will become axial, when this component will become like this. So that is one thing, okay, we have to see. So it means when this angle we can just say this angle is 90 degree. Suppose let's say this is alpha and this is beta. When this beta equal to 90 degree, when this beta equal to 90 degree, then this component will become like this. Okay, or what we can say, yeah, this component or this angle. Suppose if this angle is 0, if this angle is 0, then also this CR, okay, will become axial. So when this theta, okay, equal to 90 degree or this angle is 0, so in both the conditions we will be having the relative velocity. Okay, so the relative velocity will be in the vertical direction. Okay, so it means that time what happened, so when this beta equal to 90 degree, okay, then what we can say, our tangential velocity component will be equal to this blade velocity. Okay, so it means we can just redraw this diagram like this. So we can just, this is our C now. Okay, this is okay, this is the what to say, CR. Then this component nothing but our CT, that is nothing but that is equal to blade velocity. Okay, so this is okay, we can take it as alpha. Okay, angle alpha. So now, okay, this is for this condition when this angle, let's say this angle is this alpha beta, if let's say this is theta. Okay, if theta equal to, in this theta equal to 0 or beta equal to 90 degree, then in that condition what happen, our velocity triangle becomes like this. It means now our CR equal to CA. Okay, so the relative velocity, okay, comes into the axial. So this is another modification. So like this, okay, we will be having many modifications in the compressors or turbines, or whenever, okay, wherever we are encountering with the turbo machineries or fluid machineries.